Hello and welcome back. Today we're going to take a look at the factorization of quadratic equations. So the factorization of quadratic equations. Now, generally, a quadratic equation is any equation that's in the form of ax squared plus bx plus c is equal to 0. And over here, a cannot be equal to 1. Now, since you guys are already familiar with different examples about factorization, I'm just going to write down each case. I'm going to summarize the different cases of factorization. Case 1 was basically when we tried to find the factorization of something like x squared plus 5x plus 6. Basically, as you can see, the coefficient of x squared is 1 over here, right? Now, over here, we just did the sum and product method. We said what multiplies to 6, this one right there, and adds up to 5. So that would have been, you just open two brackets, you write the coefficient x, and then you say, all right, what adds up to 6, and what basically, multiplies to 6 but adds up to 5, which would be 3 and 2 in this scenario, right, equal to 0. Now, if you want to check whether you factorized correctly, you could have gone ahead and expanded your factorization like this. That would have given you x squared plus essentially 2x plus 3x plus, so basically 3 times x, and then 3 times 2. 3 times 2, that's 6. So it's x squared plus 5x plus 6, which is indeed what you had at the beginning. Now, in case 2, that was when you had a common factor. For example, in 2x squared plus 10x plus 12, initially you might think, well, the coefficient of x squared, or the leading coefficient, is not 1. So what do we do when the coefficient is not 1? Well, it's actually different over here because you can actually divide these all by 2, right? So there's a common factor between them. And that leaves you with x squared is equal to plus 5x plus 6 again. So it's the same thing as the first one, but this time you just have to put the 2 outside. All right, you can either divide it or just bring the 2 outside. And that would give you essentially 2 on the brackets outside. I'm basically factoring out of 2. X plus 3 times x plus 2. All right. Now, case 3 is when you have a perfect square. So when there was a perfect square, for example, in 4x squared minus 9 is equal to 0. Essentially, what you had to do is, if you remember the difference of two perfect squares, where the two numbers are perfect squares, the same thing applies here. What are the perfect squares in case 3? Well, if you raise 2x to the power of 2, you get 4x squared. So that's a perfect square. And also, if you raise 3 to the power of 2, you get 9, which is also a perfect square. So 2x to the power of 2 minus 9 to the power of 2 is the difference of two perfect squares. A squared minus b squared is equal to a minus b times a plus b. This was the general rule. So over here, you could have just written this as, all right, 2x minus 9 one time, and then 2x plus 9. Now, the fourth and final case where things get a bit more difficult is when you have a quadratic equation where the leading coefficient is not 1, but there's no common factor, and then actually there's no perfect square as well. So how do you do this one? Well, in order to solve these types of questions, all you have to do is basically you draw a cross. This is A, B, and C. Which number multiplies to AC? That would be 3 times 6, that's 18. And then which number adds up to 11? Right? So what multiplies to 3 times 6, which is 18, but adds up to B, the coefficient of x, which is 11. So think about it. 3 times 6 times 3, that would be 18, but that would add up to 9. And then what about 9 and 2? 9 and 2 actually does add up to 11, and they actually multiply to 18. That works. So how do we do this then? The next step is to decompose your middle term into, for example, 9 and 2. It's 11x, right? So 9x and 2x adds up to 11x. You can decompose it. So you're going to write this as 3x squared plus 9x plus 2x is plus 6. All right. After that, you just factor out of the common terms that you have. So out of this one, this lot, you can factor out of 3x. That would give you essentially x plus 3. And out of the other one, you can factor out of 2. So that would give you x plus 3 again. Now notice that these two middle terms, these two essentially terms, are the same for both of the sides. Okay, if you reach the point where both of these are equal, then you've done your factorization correctly. So then your final factors are 3x plus 2. One of these is just extraneous. You don't need to write this one, for example. And the other factor is x plus 3. There you go. That's the factorization done. Now you can go ahead and check this if you want. You can just expand it and see whether you get the original equation. So you can, let me do that right here. Let me write check. If you expand this, 3x times x is going to give you 3x squared plus 3x times 3, that's going to be 9x. And then 2 times x times 3. So plus 2x plus 6, which would give you 3x squared plus 11x plus 6. There you go. Now there's many different methods of doing this. You can also do the box method, but I'm not going to get into that. I think this is actually the easier method compared to that. But in the future, I will also be uploading how to do that as well. Now let's go ahead and take a look at another example. For example, B, a factorization of, for example, you can have something like 3x squared plus 13x plus 4. So over here, you draw the cross again. You draw the, not the cross, my bad, basically the times multiplication sign. So what multiplies to AC? That's going to be 3 times 4, that's 12, but adds up to B, which is 13, right here, that's B. Now, what multiplies to 12, but adds up to 13? That's really super simple. Well, 12 and 1, right? Once again, decompose the middle terms into 12x and 1x. So you're going to get 3x squared plus 12x plus 1x plus 4. The next step is to just factor out of each lot, the one that is common to both of them. In the first one, the common factor is actually 3x. So if you factor out of 3x for 3x squared, you get x. If you factor out of 12x, you get 4. Now, out of the other one, you can only factor out of 1. So you get x plus 4. And as you can see, these two things are equal to each other. The final and last step is to write the factors, 3x plus 1 and x plus 4, and you're done. There you go. All right. That was it. I hope you understood this, and good luck.